Hi everyone, today we are going to start with a new series which is Interview Preparation DSA series, in which we are going to do most important DSA questions that were asked in some of the interviews or that will be important for you in your upcoming interviews. So today I am going to focus on this easy problem. We are going to go forward and we will do medium level questions, hard level questions, but this question seems easy but is asked in a lot of interviews in a different way as well. Okay, so let's start with it. So the question is find equilibrium index. So let's first understand the question. So for a given array, find and return equilibrium index of that array or list. Okay. So equilibrium index of an array is an index I such that the number of elements at indices 0 to I minus 1 is equal to the sum of the elements at indices I plus 1 to n minus 1. So what does that mean? Let's understand it with an example. So here you can see an array, right? This is an example 1, 3, 5, 2, 2. So you can see 5 element which is at index 2. So 2 is our equilibrium index. Why is that? Why we are saying this place is in equilibrium? It is because as the question said that from elements 0 to I minus 1, okay, and I plus 1 to n, sum of all these elements like from 0 to I minus 1 index and I plus 1 to n index. Sum of all these elements on left and right of that index should be equal. So here you can see 1 plus 3 is equal to 4, right? And here also 2 plus 2 is equal to 4. Okay. So we have to find this index in any array, right? So also how it is asked in the different interviews is that they will ask you find all the equilibrium indexes, right? So that is also easy. I'll tell you how you can do that. So this question can be asked in different ways. You have to understand the concept first, like how we are going to do it. Okay, so let's start with the approach. I hope the question is clear to you that we have to find an index from which on the left side of it all the sum of the elements and on the right side of it all the sum of the elements is equal. It is just like an equilibrium, like equilibrium as the normal word states that it should be equal on both sides, same way. So all the sum of the elements on the left side and sum of the elements on the right side should be equal. That index is only an equilibrium index. It is not that it should be always middle element, it can be any other element, and there can be negative elements as well in your array. Okay, now let's come back here. Okay, here you can see another example. As I told you, there can be negative elements as well. So here you can see you have 7 as the size of the array. Okay, you can see 7 as the size of the array, and these are all the elements in the array, right? So 2, 3, 10, minus 10, 4, 2, 9. Here you can see 2, 3, 10, minus 10, 4, 2, 9, which can be the equilibrium index. It is saying second index is the equilibrium index. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Second element, that means 10. On the left side of 10, the sum is 5, right? And on the right side of 10, minus 10, let's write it here. Sorry, minus 10 plus 4 plus 2 plus 9. Okay, 11, 15 minus 10 is equal to 5. So that means 5 on the left side and 5 on the right side. See, this negative element has impacted the equilibrium index a lot, right? So that's why 10 element, which is at index 2, is the equilibrium index. Okay, so this is how it is going to work. I hope the question is clear to everyone that how we are going to solve our equilibrium index, right? So let me remove it. Okay, so now let's see what approach we are going to take. Okay, that is very important, like how we are going to solve the question. So the first approach that comes into my mind is that let's say I start from first level. Okay, I start from here and I see on the left side of it, and I will take the sum of all the elements on the right side of it. Okay, on the left side there is nothing, and on the right side 3 plus 5 plus 2 plus 2, which is 8 plus 2, 9, 10, 11. So that means on the right side it has 11. So I'll check if the sum is equal. No, the sum is not equal. So that means it is not an equilibrium index. Now I'll come to 3. Here what will happen? On the left side of it, it is 1. On the right side of it, 5 plus 2, which is 7, 8, 9. 9. So what do you think? On the left side, the sum is 1. On the right side, sum is 9. So this is not an equilibrium index. Then we come to 5. On the left side, 3 plus 1, which is 4. On the right side, 2 plus 2, which is 4. So we found our equilibrium index. There can be many equilibrium indexes. As we move forward, we can find them. But in this question, we have to find only one equilibrium index. Okay. So this is a brute force approach that I am talking about. That means on each element we will go and we will find the left sum and the right sum. Okay. So, but for this approach, what is going to be the time complexity? If I take this approach, I'll go on each element and I will find the sum on the left side and on the right side. What do you think? What will be the approach? What will be the time complexity? So the time complexity for this is going to be big of n square. How it is going to be? Let me explain. So if I am on the first element, let's say, okay. So on the left side, there is nothing, we don't have to travel anything, but on the right side, we have to travel n minus 1 elements, right? So for the first index only, the time complexity is big of n minus 1 to find the sum on the left side and the right side. Now we come to 3. Again on the right side, how many elements are left? Because we are at the first index. So n minus 2 elements are there on the left for index 3. For index 1, for index 1, on the left side, the elements are 1. Let me write it here, left and right. Okay, and let me write it here. For the first index, it is going to be on the left side there is one element, and on the right side there is n minus 2 elements, right? These two elements are left, 3 and 1. On the right side, this is the element. Now second index, I am at this index. So on the left side there is going to be 2 elements, and on the right side there are going to be n minus 3 elements, right? So as you can see, as we move forward for third index as well, on the left side 3, on the right side n minus 4 elements, right? So if you take the sum of all these, so let's say this is sum of these elements that we are traveling is n minus 1. On second index as well, we are traveling n minus 1 elements. On the third index as well, we are traveling n minus 1 elements. So if there are going to be n elements total, right? And for each element, we are traveling n minus 1 elements already. So it is going to be this time complexity, and this is actually n square minus n. These are the number of operations we are going to do, and what is the maximum value of n, like power of n, which is n square. So it is going to be big of n square. If we go with this approach, if we are going on each element and we are finding on the left side what is the sum, on the right side what is the sum. Also remember, we don't have to calculate that element. We don't have to consider that element in the calculation. We just have to calculate the sum of all the elements on the left side and all the elements on the right side. I hope this approach is clear to everyone, that this is a brute force approach. Like brute force means that we are not thinking about it. This is the first thought that comes into our mind and we are doing it. Okay. But this is not acceptable in interviews. So we are going to go with a better approach. So let's see how we are going to do that. And now let's understand the efficient approach. Okay. So let's think about it. So first of all, what we are going to think is, let's say if we have the sum of all the elements. Okay, so let's say 1 plus 3 plus 5 plus 2 plus 2. What is the sum of all these? I think 30, right? This is the total sum of the array. Okay, which is 30. Now think about it. For each element, as we go forward, we need to find the left side sum and the right side sum. That means sum of all the elements on the left and on the right. Okay, so how we are going to optimize the previous thing that we saw, previous approach that we saw. So let's say I'm on the first element. Okay, on the left side of it, let's say left sum is 0 because there is nothing, right? And on the right side, what is the sum of all the elements? 3 plus 2 plus 2 plus 2, right? So that means only from the total sum, we are removing this one element at which we are at, right? So that means for index, let me write it here. Okay, so for index 1 0, let's say index, right, here left sum, and here we are going to do right sum. Okay, so index, let's say 0, the left sum is going to be 0 for 0 index, and right sum is going to be 13 minus 1, right? That means the total sum, okay, minus the index at we are at whatever we are at, the element there is, we are removing that. Okay, so that means 12. So left sum is 0, right sum is 12. Are they equal? No, they are not equal. So we are going to move forward at index 1. Okay, so at index 1, what is going to be there? So left sum is going to be, only there is one element, right, which is 1. And right sum is going to be, so whatever the right sum before was, can we remove this 3 from it, right? So for 3, the right sum is going to be 5 plus 2 plus 2, which is 9. So if I remove 12 minus the current element at which we are, right, 3, it is going to be 9. So left sum is 1, right sum is 9, right? So that is going to be not equal. 1 is not equal to 9. So that means we have to move forward. So let's say I am here. Let's say this is a current element. Okay. So current element is now 5. That means index is 2. Current index is 2. Okay. So let's say I am at 2. So left sum is going to be from the element I have come from, right? If I add this element in my left sum, let's say 1, it was 1 before, and we add 3 to it. Okay, so just the previous element, that means current minus one element. If I keep adding to my sum, left sum, it will accumulate the left sum, and if we keep removing the current element from the right sum, that will accumulate our right sum for a particular index. Let me make you understand this. So 1 was the left sum. So from which element we are coming from? 3. So 1 plus 3, it is going to be the left sum for this element, which is index 2, right? And right sum is going to be whatever the last right sum was, 9 minus current element, that is 4, and the left sum is also 4. So these are equal. So we got our equilibrium index. Okay, and here we are not going for each element, we are not traveling the whole array, right? What we are doing is, initially we are taking the total sum, right? Then one by one, whichever element we are going on, we are keep subtracting something and adding something to left sum and right sum, right? This is what we are doing. So in this, we are only traveling the whole array once, only once. So that means if we are traveling the whole array once only, so that is going to be big O of n, right? The time complexity is going to be big O of n. Okay, so from big O of n square, we have come to big O of n with this approach. I hope you understood this approach. What we are doing is, on whichever element we are at, okay, so let's say we are at 0 index. So on the left side, the sum is 0. On the right side, the sum is total array sum minus 1. On just we have to remove the current element. Okay, so that is going to be 12. So when we move to 3, what we did was, we added this 1 to the left sum of 3, right? Obviously, so whatever the left sum was, we added this 1 to it. So 0 plus 1 is going to be 1. And when we are at this index, okay, understand this. So from 3 to 2, we know the sum. It is the right sum of 1, right? It is already in the right sum, right? So if I want the sum from 5 to 2, we just have to remove 3 from it. So this is what I did. So it was already 12. I removed 3 from it and it became 9, right? So now we know the right sum of 3. And the left sum of 3, we added the previous element into this left sum, right, which is 1. Okay, now we came to 5. So we already know the sum from 5 to 2, which is 9. Okay, so if I want the right sum of 5, what we are going to do, we are just going to remove 5 from 9, which is 4. Now we got the right sum of 5. Now on the left side, what we have done is, we have just added this 3, because we just came from 3, right? We will keep adding the elements from where we are going forward, because if we add 3 to 1, this is already the left sum of 5. So that is what I did, 1 plus 3, which is equal to 4. So 4 equal to 4, and that is our approach, and we got our equilibrium index, right? So I hope you understood this approach. Let's write the code and then we again go through the approach and we will understand it. Okay, I hope you got it. So let's go back. So here, let's write the approach. Okay, so what we understood. So what I'm going to do is, first of all, I need a total sum of the array, right? Total sum is equal to initially 0. Also, what variables I need? I need int left sum, which is initially 0, and we are going to take a right sum, which is still equal to 0, right? Now what we are going to do? We are going to find out the total sum of the array. Int I equal to 0, I less than arr dot length I plus plus. Okay, here what I'm going to do is I'm going to find out total sum plus equal to arr of I. That means I'm going to take the whole sum of the array and going to add it into the total sum, right? Or what we can do is, we don't need the total sum, I think, right? Why? Because I'm going to add this total sum into right sum only. Okay, so let's do this. Okay, so right sum right now is the total sum. Okay, now what we are going to do? So for int I equal to 0, I less than arr dot length I plus plus. So here what I'm going to do is I'm going to add what? I'm going to go on each element now. Okay, you have to understand this thing, that now I'm going to go on each element. Let me remove this. Okay, so if I take an array here, okay, so let's say we have 5 here, 2 here, 2 here, 1 here, 3 here. Okay, so this is the array. So what I'm doing is, now I am at 0 index. Okay, 0 index means this I is going from 0 to n. So here I have I and we have 0 index here. So what I'm going to do is, for this left sum is 0 and the right sum is total sum that we have got from the array, which I have added in the right sum, minus this current element. Okay, so that means this sum I can get by removing 1 from the total sum. Okay, so this is what I am going to do. So here, right sum for 0th element is going to be arr of wherever I am, arr of I am going to remove from r sum, which is right sum. I am going to remove arr of I from it. So I got the right sum of that particular element. Okay, now what I'm going to do is I'm going to check if left sum equal to right sum, r sum. Okay, so why I'm doing this right now is because left sum is 0. For 0th index, left sum is 0. Okay, for the right sum only we have to remove the current element. So now 0 and whatever the right sum is, I'm going to check that, and if they are equal, I'm going to simply return that index, which is I. Okay, so let me show you. So let's say for it is 0, it is 1, it is 2, it is 3, it is 4, right? So here we have, let's say 1, 3, 5, 2, 2. Okay, so if I start from here, okay, I am at this index. On the left side the sum is 0, on the right side I have removed from 1 from the total sum, which is going to be 12. So they are not equal. Okay, so before moving to 3, okay, before moving to 3 I have already checked, can I add this 1 into my left sum, right? So if I add 1 into my left sum, I don't have to go again and add n minus 1, right? Before moving to I minus 1, before moving to 3, which is the next index, I can add this 1 into my left sum. So what will happen? Left sum will become 1 and right sum will still be 12. Okay, so when I again run the loop, what will happen? This will again calculate the right sum. Okay, right sum is going to be 12 minus 3, which is 9, and then we will compare 1 and 9. You can see everything is going to work fine here. Okay, so this is an easier way. So let me just write this and show you what I am telling you. So I am going to add left sum is equal to left sum plus ARR of I. That means before going to the next element, because after this loop will run again, right? At that time, left sum will be 1 and your right sum will be calculated again. Okay, this is just a small thing that we can do. Otherwise, the simple way, if you don't want to understand this, we can simply add left sum here as well. Like we can keep adding in the left sum here and we can keep checking. But this is an easier way and much better way, so that interviewer will also understand that, okay, before moving to the next element, you are adding the current element into the left sum. Okay, because this element is going to be the left sum for the next element. Okay, this is going to be added to the left sum. Okay, so this is how we can solve this question. You can see we are only going on each element one by one, and we are doing it in big of n time, right? So here we can return what? Yeah, -1. If there is nothing, we have to return -1. You can see here as well, I think we have written this. Yeah, return -1 if no such index exists. Okay, so this is how it works. I think this should work fine. Let's run this and see. Okay, execution completed. You can go on the test cases and you can see every test case passed, right? So what you can do is, this is our platform ycodeverse.com, and this is a question ID that I am using, which is in the, if we go back, you can see this is a question DSA playbook that we have, that you can buy for only 500 rupees if you want. This will actually cover all the questions that are important for the interviews, all the important questions. The main problem we face is that we don't know exactly how many questions we have to do in each of the arrays, binary search, string, greedy algorithms, all these things. We don't know in each topic how many questions are important. But if you do these, because they are level wise as well, you can print array, then sum of array, largest element, then medium elements, medium questions, and hard questions. Everything is covered. So if you want, you can go and buy this at only 500 rupees. 500 plus GST, which is 590. This is an offer that we are giving right now. It can be increased anytime. So because a lot of students are buying it, so just go and start your practice now only. So let me go back to that question. Okay, so it is already here. So we have already solved, all the test cases were passed. So let me submit it as well. Okay, and also there are AI tools here. If you see, if you want to get a hint, you want to explain your code, you want to analyze the complexity, everything is there, right? So you can take the help of AI as well. So I hope you got the question, right? You understood everything, and we are going to solve these questions again and again in the upcoming videos, like new questions every time, and we will prepare for the interview together. So just do one thing, just subscribe to our channel, click the bell button so that you can get the notification as well, because this series is going to be very important for you. Thank you.